1,
We're going over a review?
We're going over the review. Is that okay?
Oh,
Is that all right?
yeah, sure.
Okay. So I would love to go over the review with you guys. Talk through what the assessment's going to be like tomorrow. We'll go from there. Sound good? I say sounds good, like I'm going to take your input. Too bad we're doing it anyway. Oh man. I'm in a good mood today. I'm always in a good mood. Am I ever in a bad mood? I don't think so. Even in my bad mood. Yeah. I'm tired. All right. What did the doctor say, by the way?
Why have we not thought of this?
AJ, what did the doctor say?
I've never had one.
Oh my God, I'm starting.
So you'll know more later.
Yeah.
Did I tell you guys I have to get a dental implant? I have to get my tooth removed. Yeah, oh, okay, so I never finished my story. I went to go get that root canal like a long time ago, and my tooth is cracked all the way down to the bone. So I have to go and get it like surgically removed. Like wisdom teeth, you know, like they gotta put me out, take it out.
Cause you pain right now?
No, that's the crazy part. They said it's cracked all the way down to the bone, but I doesn't hurt me at all. So on the 13th, I have to go and do my consultation, and then they'll go. It's like a really crazy. They take the tooth out, and then they like put a metal spike, like a metal like screw into my jawbone, and then that has to heal for like a month, and then they'll go in and like screw on my tooth.
Oh no.
So I'm gonna have just like a little metal screw sticking out of my gums for like I don't know how long, like a month. It's gonna be till like after Christmas. I told her, I said it to me down, so I was like, do I need to like? It's not cosmetic. Like nobody's gonna be like checking out back there and like, oh, you don't have a tooth back there. Like if it was like this. But like it's just a molar. And he said no, because it's like because you clench, because you chew. Like if you don't have a tooth there, the teeth will start like shifting around it, and like I might crack more teeth back there. Oh my god! It's like thousands of dollars to get a fake tooth. I'm gonna spend thousands of dollars on this thing I'm never gonna.
It's probably made of like a box.
I know. Can't I just like get a little like rock from outside? And...
You look little George Washington.
All right, enough of me talking. Let's do the chapter 6 review now. So, just as a reminder, now we are chapter 6. All of the formulas that you will need are right here on the pink sheets. You do not need. Okay, so the first one, the first piece here says confidence interval for the mean. X minus E less than mu, or X bar plus E. This, and then it gives you the equation for E. And it also gives you the equation for E when it's a t-score rather than a z-score. We'll talk about which is which in a second. It also gives you minimum sample size, which is one of the questions on the review that a lot of people are like, what do you do with that? So minimum sample size is right there as well. Past minimum sample size, we don't do anything past section 6.2. So really the bottom chunk of this thing, after point estimate for population proportion, you don't need that. Okay? That P with the little funky triangle above it, you don't need that. It's actually called P hat. P hat, you don't know P, you don't need P hat. We don't talk about anything down bottom of there. Yeah. So this whole chunk of chapter 6 you don't need. Remember that for your tables, you really, for the z-score tables, for confidence intervals, you really only need this little piece down here. For the z, and then the t is just the next page. So just know where things are for tomorrow. All right. Now, just to kind of summarize, because again, I wasn't here on Monday because of I'm sorry, I forgot to say this. Did I say I won't be here tomorrow? I won't be here tomorrow. I know, I got a funeral to go to. I would rather be here, trust me. But it was my wife's grandma. She was like upper 90s. It was time. But I got the funeral to go to tomorrow, so I will not be around. So I want to really kind of make sure you guys understand everything because I won't be around for you guys to ask me questions. So section 6.1, confidence intervals for the mean. Now, this section 6.1 was all about when you have sigma, right? When you have sigma, when you know sigma. And basically all of chapter 6 is about when you don't know population mean, how can you estimate population mean? When you don't know what the true population mean is, how can you estimate where you think it's going to be if you run a sample? That's all of chapter 6 in a nutshell. Section 6.1 is how to do that when you know population standard deviation, which is really like, how are you ever going to not know population mean, but know population standard deviation? That seems so weird, whatever. But they're two different calculations, so we talk about it. So section 6.1 was, if you know sigma, if you know population standard deviation, you can use sigma. If you don't know sigma, that's section 6.2. Now remember the stipulations for this. It could be a large sample, so I have to have n value greater than or equal to 30, right? And this is saying, okay, if I want to find an estimate for the mean, I need to take a sample of something greater than or equal to 30, or I have to know that my population is normal. I have to know my population or approximately normal. I have to know it's either normal or approximately normal. And if I know that, then the stipulation of n greater than or equal to 30 can go away. I could use a sample size of 10, and it would still come out okay. Okay? Now, for your estimate for your error margin has the formula ZC times sigma over the square root of n. Now, how do you get ZC? Well, I need to tell you how confident you want to be. Remember, the higher the confidence, the bigger your range needs to be, right? If I want to be 99% confident that my mean is going to fall between that interval, remember, think of it. I'm throwing darts. If I'm 99% confident I want to hit the dartboard, that dartboard needs to be really big, right? If I want to be 60% confident I want to hit it, okay, that dartboard can be smaller because I'm less confident that I'm going to hit it, right? So they're directly related, right? When one goes up, the other goes up. When one goes up, the error margin goes up. And to calculate error margin, I take ZC, which is from the level of confidence. Your ZC times sigma over square root of n, and its sample size, sigma's population standard deviation. This is the formula for minimum sample size. So if you want to be within a certain range for your mean, I can calculate the minimum sample size needed to secure that range. And you would just take ZC times sigma over E. That's just a manipulation of that formula, right? That's just an algebraic manipulation of that. And then to actually truly find what the interval should be, you just add or subtract E from X bar, from your sample mean, from X bar. And that will give you the range of your population mean. Now, that was section 6.1, all dealing with sigma and Z. If you don't know sigma, you could always calculate the sample standard deviation. That's where the lowercase s comes in. Okay? This is a more common example. If you're trying to guess at what the population mean is going to be, more than likely you don't know population standard deviation either. But you could always run a sample. You could always run that sample, which is what you had to do for number 2. You'd always run that sample and calculate the standard deviation. But then when you do that, you have to use a t-score rather than a z-score. You have to use a t rather than a z. Now, how do you find the t critical value? Well, that depends on the number of degrees of freedom that you have. Remember the degrees of freedom, which I guess is not up here. The degrees of freedom is always n minus 1, right? Your sample size that you take minus 1. You take your sample size minus 1, your degrees of freedom. You take your level of confidence, and then you figure out what your t-score should be. Here's the degrees of freedom, your levels of confidence. I'm always going to be sticking to the levels of confidence that are on these papers. I couldn't ask you about anything else. And then you take your t-score times S divided by radical n, where S is the sample standard deviation and n is the sample size. And then you use that to create your error margin. Notice that the error margin formula, or the confidence interval formula is exactly the same from both sets. X bar plus or minus E. X bar plus or minus E will give you the range for mu. All right, so let's get to it. Let's actually do the problems that I gave you guys. First one here. You want to know the average ACT score of Lake High School students. You know that the population standard deviation is 2.4. So again, like how do I really know population standard deviation? I don't know. The population standard deviation is 2.4. You want to be 80% confident that you're within 0.3 points of the mean. What is the minimum sample size required? Okay, let's take a look. Now, minimum sample size formula. I'm going to go back here. Minimum sample size formula is right here. Could have just copied it off the last slide, but that's okay. N is equal to ZC sigma over E squared. Yikes, poor handwriting. ZC sigma over E, over E, then squared. Get on the right page. All right, now let's identify each one of these things. What is ZC? How do I get ZC? What is ZC dependent on? The confidence, right? The confidence. So look down here, those critical values. If my confidence is 80% confident, what's my ZC? 1.28. And 1.28. And that's just from right here. Just that little table right there. It's on your Z-score tables. We had never even used that, right? We were always stuck with using the big tables, right? Just using that little one right there. 1.28. Okay. You know the population standard deviation, sigma, is 2.4. And what is this? You are within, you want to be 80% confident that you are within 0.3 points. What is that? Your margin of error. So E is 0.3. Okay, let's find the minimum sample size. So 1.28 times 2.4 over 0.3 all squared. 1.28 times 2.4 divided by 0.3 squared. 105. Round down. 105. You need to sample at least 105 students. At least 105 students. Yeah.
What table are you using?
For Z, just your normal Z-score table. Yeah. But really all you need, so this is your Z-score table right here, right? All you need is that little one down there. Yep. That's on there too. Okay. Who's not here? Higginbotham is not here, Mrs. Brown. Mrs. Brown, I'm going to predict which student you're going to ask about. Matthew Higginbotham is not here. Thanks. Bye. Man, I hate getting that call. We good there for that one? Okay. Let's take a look at the next one. A random sample of 10 adults gives you the following screen times per hour. Or per hour. Ooh. Screen times in hours per day. Assuming that the amount of exercise per week. Exercise? I think I meant screen time. Assuming that the amount of screen time is normally distributed, find a 95% confidence interval for the population mean, show work for the sample mean and the standard deviation. show work for sample mean. Okay, we can just find the sample mean. Right? X bar is going to be 4 plus 3.2 plus 5.8 plus 7 plus 6 plus 3.75 plus 2 plus 1.5 plus 3 plus 2.5. Did I punch everything in right? 4, 3.2, 5.8, 7, 6, 3.75, 2, 1.5, 3, and 2.5. So that divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, stupid, it told me. 10. 3.875. 3.875. Let's round that. Let's say 3.9. Okay, there's X bar. Let me fill in my table here with my values. 4, 3.2, 5.8, 7, 6, 3.75, 2, 1.5, 3, and 2.5. Why am I giving you this table? Because I need to find S, right? I need to find S. And this is S, not sigma, correct? This is not population. This is a sample. Okay, now, to do that, I go back to the chapter 1. Nope, that's a lot. Chapter 2 formulas, and I see S is it. Oh, that's frequency distribution right here. X minus X bar squared divided by N minus 1. Our formula for standard deviation. And this is just coming straight from the chapter 2 formulas. S is equal to the square root of sum of X minus X bars squared divided by N minus 1. That's how to find standard deviation. All the way back from chapter 2. You did this before. Promise. Okay, so now I'm just going to run those values. I'm going to find X minus X bar squared. I'm going to punch in, let's do 4 minus 3.9 squared. Get that value, 0.01. Do that same thing, but now instead of 4, I want 3.2. 0.49. And do 5.8. This is a little time consuming. 5.8, and you got to be very careful with your work. 3.61. Okay, we've got just a singular 7. 9.61. We got a 6. Oh, whoops. Go to 6. 4.41. Let's find the 3.75. 3 insert 0.75. 0.0. Well, let's round it to 0.02. We'll go here hundreds. It's so close to the mean. It's really almost negligible. We've got a 2, which is 3.61. We got a 1.5. 1 insert 0.5. 5.76. We got a 3. Let's jump back to this one. 0.9 squared to 0.81. And we got a 2.5. $1.96. Okay, those are all my X minus X bar squareds. Let's add all those up. I'm going to do it like this. 0.01 plus 0.49 plus 3.61 plus 9.61 plus 4.41 plus 0.02 plus 61 plus 5.76, 0.81, 1.96. Okay, I'm going to double check. 0.01, 0.49, 3.61, 9.61, 4.41, 0.02, 3.61, 5.76, 0.81, 1.96. Bingo, 30.29. Now, you might have gotten something close to that. You might not have gotten that exactly, The only reason you might have something different is I rounded that to 3.9 when I did all those calculations. Right? If you had left that as 3.875, yeah, it might be a little different. Probably pretty close, but it might be a little different. That's okay. But just show the work. Just show me that, and I'll be okay with it. So S is equal to the square root of 30.29 divided by, now what am I going to divide by now? 9, n minus 1. So I got 30.29 divided by 9, square root 1.83. 1.83. All that work just to find standard deviation, right? I am just beginning this problem though, right? Find a 95% confidence interval. Okay, so the confidence interval, I need E. I need E. And E is TC S over radical N, right? Okay, what is TC? What's my critical value? I gotta go to my 95% on my, now, why am I using T and not Z? Right, because this isn't population standard deviation. That's S, lowercase s, that's sample standard deviation. So I gotta go to T-score, 95%. I gotta get my ruler, and degrees of freedom is what? 9. So 95% with 9 is 2.262. 2.262. So 2.262 times 1.83 divided by the square root of 10. See, that's an n. That's a straight up n, not n minus 1 there. We good? Okay. I saw some weird looks. I didn't know it was. So we'll do 1.83 divided by radical 10. And then multiply by 2.262. 1.31. So E is 1.31. And now I add and subtract that from X bar, from 3.9, right? Whatever X bar you used, 3.875, 3.88, 3.9, whatever. So I'm going to take 3.9 plus 1.31, and then 3.9 minus 1.31. So between 2.59 and 5.21. 2.59 and 5.31. Or 5.21, excuse me. That's the range from you. And I am 95% confident in that. I'm 95% confident in that. Because my confidence was so high, that's why my range is actually kind of big, right? In comparison to my standard deviation and such. All right, can I go to the next one? All right, a random sample of 40 men found that their height had a mean of 5.9. Okay, X bar, 5.9. With a standard deviation for the sample as 0.4. Find a 95% confidence interval for the population mean. So basically, I've done the hard work for you. I found S. I have found X bar. I just want you to find the confidence interval. Okay, N is 40. And I'm glad that it's over 30 because I'm not told that the population is normal. But find a 95% confidence interval. Now, am I going to use T-score or Z-score? T, because again, it's a sample. So I'm going to say E is TCS over radical N. Okay, let's find critical value. What's my degrees of freedom? 39. So 39 with a 95% is 2.023. multiplied by S over square root of 40. So 0.4 over radical 40 times 2.023 is let's round it to the nearest 100. 0.13. 0.13. Okay, we go above and below my X bar with that. So 5.9 plus E, 5.9 minus E. So it ranges from 6.03 to 5.77. So 5.77 to 6.03. So I am saying I am 95% confident with those parameters that the average, that the population mean falls between 5.77 and 6.03. Questions about that? Okay, take a look at the next one. From a random sample of 24 months, the mean number of tornadoes per month in the U.S. was about 100. Assume a population standard deviation of 114. Find a 90% confidence interval for the population mean. You know what's interesting? I remember this problem from last year. I copied this one straight out of the book. We can't even do this problem. Why not? Why is this problem invalid? It's not 30, and I am not told that the population is normal, right? I copied this one straight out of the book, and I shouldn't have. We shouldn't even be able to do this. Let's assume the population is normal. Okay. Let's assume it's assuming the population is normal. Okay, so n is 24. The mean X bar is 100, which is crazy. 100 tornadoes per month. Assume a population standard deviation of 114. Sigma. How is sigma more than X bar? But whatever. Find a 90% confidence interval for the population mean. Okay, so is this Z-score or T-score? Z-score. Z-score. Why? Because it's sigma, right? Because it's sigma. My error margin should be ZC sigma over square root of n. ZC sigma over n. Okay, so in this case, I go to my Z-score table. I go to that tiny little table at the bottom, and I want to be 90% confident. So I see 1.645. 1.645. Sigma is 114. N is 24. Okay, let's run that value. 114 divided by radical 24 times 1.645. And I get 38.3. And now we go above and below the mean, right? So that is 138.3 on the high end. So 100 minus 38.3, 61.7, excuse me. Questions about that? All right, last problem. Oh, we've kind of been talking this through, right, as we've been going. How does changing the level of confidence, sample size, standard deviation affect the width of the confidence interval? Think of it like you're playing target practice, right? Think about you're throwing a dart at a target. You want to be more confident? If I increase the level of confidence, what does that do to the interval? Makes it bigger, right? I want to be 99% confident. That target better be really big. The interval must be huge, right? Must be really wide. Now, what if I increase my sample size? What if I increase my sample size? It decreases my interval, right? Because I am going to get more and more accurate if the higher the n value goes. Okay? Because if I sample more people, I should get closer and closer to the true population mean. So if I increase sample size, confidence interval is going to decrease. Standard deviation. If I increase standard deviation, what's going to happen to the confidence interval? It's going to get wider and wider and wider and wider, right? If I increase standard deviation. Because that means the data is going to get more spread and more spread and more spread. All right, let me turn off the video.